the subsequent cells, we just have to push it up back to the value class. So why this code change? Again, I already mentioned it is for better code readability and maintenance. And this is a short in-class activity for you to warm up. 5 minutes is the time I give you. The reason I am giving you only 5 minutes is because you already have the code. Build topo and backward is something not alien to you. You already implemented that. And for loop is also implemented. What you do is you copy paste and put the code in the value class under a method named backward. So def backward parenthesis colon followed by the code which we already implemented. I give you 5 minutes for that. Anyone who is done with that task can show it to me, and then I'll give you a solution. I'll pause for 5 minutes. What will happen anyway? The code will be given. No, don't have that attitude. Please do it. So we give you 15 minutes to complete this exercise. I've given you most of the code so that you can focus only on the logical part. That is accumulation of gradients and building topology, calling the backward. Remaining everything I handled in the code, starter code already. You need to type it. So once we complete this, then we switch over to drawing parallels between value class and PyTorch, and then we have another exercise. So please complete this quickly.
Yeah, by the way, anybody could copy paste? Did you copy pasted anything in the Tantric? It's okay. So we will not penalize anything. We want to know. I want to see the crux, the robustness of the system. I said you can't copy paste. If you can copy paste, please let me know.
So up to this point, you already have the code here, the value class, where we use this underscore backward. You implemented that as part of the d underscore methods. This code was already shared with you. You completed an assignment. Then we implemented this cell where we did a topological sort, build topo. And then we have a sequential call of backward on all the nodes from right to left. So I am saying that whatever code is there in this cell and this next cell, it has to be moved to this backward method. That is the only task.
Yeah, how many of you submitted? Please raise your hand.
Method signature I gave you, but there is something missing in the method signature also.
Okay,
so 5 minutes I'll give you and quickly show me the code.
You can just click
There's
on
nothing new, it's just refactoring your code, reorganizing it. That's it.
So we are giving 15 minutes. Already 5 minutes are done. 10 minutes more. Yes, Sripooja, can you zoom a little bit? Everything is given in the notebook itself. You need to just write a piece of code. Just build that value class.
Oh, this is a weird case. For someone, the hidden test case passed, but the visible one did not pass. It doesn't update here?
Refresh.
I clicked on refresh, but this is not getting updated.
Once it does refresh, you
can after click on refresh. I clicked, so that's the reason this. Okay, you can do it. So 1, 2, 3, 4, 5. 5 green stars so far. Nothing is happening. That is. So if anyone has already completed the code, you can raise your hand. We'll quickly come around and check the code.
Yeah. Did you got the notebook, the feedback? Yes? Yes, Sripooja, practice notebook for this is started?
The old practice notebook, they
Old
can
one.
use that. Yeah.
Yeah, you can use the old one. You can open the previous practice notebook and code it. Practice notebook will be continuously
Yeah,
the
just
same.
refresh now.
I refreshed it a couple of times, sir. We can click on evaluate again. Evaluate, this is not getting updated for some reason. Graded and stars. I tried it so many times.
Table has been updated, but yeah, I have a small question to most of you. For the forward feed, Sripooja is using an activation function. Which activation function are you using? How many of you know it is ReLU? How many of you know it is sigmoid? No. How many of you know it is tanh? Sit down, please. Yeah. So we are using tanh. So when I asked few, nobody could answer. So we are using tanh. Please remember, why are we using activation function and which activation function we
Yes,
are
more
using?
5 minutes.
Okay.
Please submit.
Okay, one more question here. If I am using tanh, what is the range of tanh? -1 to +1, correct? If I have a weight of -6 or +6, what will happen? So it will be in 1 or -1, right? Within the range, correct? Yes? Am I correct? Or is a negative weight have an effect on tanh activation function? Does a negative weight have an effect on tanh activation function? What does bias do on tanh activation function? If you change bias from 0 to +5 or +10 or minus, what happens? What changes happen? What happens with the
Yes, you just click on
respect
evaluate.
to bias? What happens to the activation? What activation function will do to your data? Yes?
Vishal, the value explodes. It goes up.
Goes off the curve. It creates an offset.
Yeah, how many of you
Okay.
submitted and got 100?
Okay, strange. One. Not exactly
Okay.
correct, but yes.
Yeah, others, please submit.
Okay. Just hold on.
If you're facing issue, please call us.
So I think around 30 students have scored 100. But for those who, where you see that the hidden test case is passing and the visible one is not passing, please check the logic of accumulating the gradients. Addition is what I showed you in the class, but for multiplication, do you have that accumulation logic or no?
Yeah, just look at this visualizer. We'll understand what I was talking about. Can you zoom a little bit? Yeah.
I see only
Since this is a linear, I'm not
submissions.
worried about this. Just select tanh. Zoom a little bit out. So that is a tanh curve. Now there is weight, right? If I go to positive, see the graph, what happens? Positive values. If I expand positive value, it compresses and it tries to accommodate. And if it is negative, just see, it inverts itself. This is the effect of negative weights and positive. Let us do for bias now. Now let's change bias to the positive. See there. You see this? That's the offset which is happening. Just now negative bias, it goes to plus offset.
Yeah, Sripooja, can you just click on evaluate once more?
So this is what you should have when you are trying to train. Because when you go to train this model, you will understand the importance. Will superimpose with the actual data set, how it tries to closer.
Yeah, Bhargav, can you just click on evaluate? So I see 112 submissions. Please submit. Yes. Okay, we'll move on to the next topic. So those who have not submitted, when we open exercise number 2, try to, because that is interconnected, check what issues that you are facing. Yeah, Sripooja, can you just go ahead, or are you going to reveal the solution? Okay, go ahead.
All right. So I think most of you got the solution, so I won't be revealing the solution. If you have issues, please let me know. I want to know who are facing the trouble and where, so that I can understand which part of the code you are facing the trouble. Is it the accumulation of gradient or is it the method call? What is going wrong? Right? So I think good number of you have already submitted. We see green stars, so it's time to proceed with our next session, the next topic for today's session. So again, all eyes here please. Stop discussing. You'll again get time when we open the second assignment. We will not be closing the first assignment. I'll give you time for that. It's a quick code that we have to discuss now. Again, you can spend more time on exercise 1. So this is exercise 1 that you completed. Now coming to the value class and PyTorch tensor. I told you we'll be drawing parallels between the value class that we implemented till date and the PyTorch methods that are being provided as part of the PyTorch library. So let's understand how close they are and what all methods did we mimic or implement in part of our value class. So now in the value class that I highlighted in green, this is how we are initializing values. Value of each neuron. What is the data that is stored in the neuron? So that is the methods that we are using. Instance of value class. We pass the value, we also pass the label, or we assign the label later. So essentially it takes one value that is float, and then we can also initialize the label then and there. But what is there for PyTorch? PyTorch, the method that we use is different. We call it tensors. Torch.tensor, then you pass the value there, and you also define the data type, which in this case is double. You know, float, int, double, everything, right? All the types of values. So we choose to use double because it can handle the precision values correctly. And then we define that A is a neuron which requires gradient. So this is basically to indicate that now this tensor not only stores the value, but it also stores a gradient value. So that's the reason we are setting that flag to true. That this particular tensor, which we are naming as A, which we initialized in the first step, requires gradient. So this was a quick comparison on how we can initialize the values. So this is the first step that we did in value class. But for this exercise, you have to do the second step, that is how we can do the same thing using PyTorch. So this is the code for that. Now that I'm displaying the code, you have the practice notebook open. Just import torch and make sure that you are implementing the torch part of the code. Take any simple math equation, C equal to A plus B. So whatever you did using value class, you have to replicate the same thing but using PyTorch tensor. And for that I'm giving you the initialization step already. So you don't have to look at the API of PyTorch. I'm giving you the method and how you have to initialize the values.
Yeah, this is for your learning only. We are not going to use PyTorch in the next classes, just to see the similarity. Yes.
So done? Do you see the value of A or some other variable name that you chose? But this time using PyTorch tensors. I don't want to spend more time on the PyTorch code because that is not our main agenda. That's the reason I'm giving you the code, asking you to type.
Yeah. Exercise open?
This is not exercise, in class.
No, in class. Use playground, please.
Yes, the practice notebook, use that. So initialized tensor value of A. Yes or no? Raise of hands. Done? Okay. So this was the first step. Now moving on to the second step. Value class, we use tan h. For that we called tan h as O dot tan h. So we do not pass the O value as an argument or a parameter to tan h function, but we rather call tan h on that instance of value class. But whereas in the case of PyTorch, it is slightly different. You have to define it in this way, that is O equal to torch dot tan h of whichever value that you want, right? So we saw that on day 3 in the week 1. So I'm using the same variables, whatever we use, so that it becomes easy for you to go back and refer. So O, the final output, whenever we had that graph, W1x1 plus W2x2 plus B, we were storing that in N, and then we applied tan h, that was giving us O. So that is the step I am using here, O equal to torch dot tan h of N. So just make a note of this, you can add a comment, keep it there. When you implement a bigger function, you can use it. Now how do you call this backward? It is the same, right? We use node dot backward in case of our value class. Wherever we use the value class, we call node dot backward. But in case of PyTorch, if you are storing the final output in the variable O, in the final tensor O, then you call the backward method on that final tensor. So you don't have to do the for loop or the build topology part, etc. So everything is handled by PyTorch itself. So you just have to initialize the tensors, build a complete network, and then you call a backward method on the final node. So we just took a deeper look at exactly what is happening in case of backward. Because this is abstracted when we use PyTorch tensors. We don't know what's happening behind the scenes. So we implemented that as part of our value class. So we know each and every step that happens as part of backpropagation. So up to this point is what you can quickly take a note and you can try. The next is about the graph. For that I provided you the starter code. It's just a method call that is vary. And I wanted you to take a look at the TorchWiz library. So we used GraphWiz, but TorchWiz is something that is used in combination with PyTorch for visualization of nodes. So I wanted to draw a parallel between both those libraries as well. For that I am giving you the starter code. You don't have to invest much time on implementing it. So how does it look? Draw dot of O is what we used so far in our assignments and in the in-class activities. O is the final node which holds the output, the final output of the neural network. And then for a make dot method that comes from TorchWiz, this is how it's called. Now exactly where is this code? You don't have to worry. You just make a note of this somewhere. In the exercise 2, I am giving you the code completely. So you can take that code versus the code that is already there for draw dot, do a quick comparison and see where is the change. Because make dot deals with tensors, whereas draw dot we made it usable with value class. So draw dot in combination with value class is how we used. Today you will be using make dot in combination with PyTorch tensors. So this is exactly how you can figure things out and compare two different notebooks. So can one of you show me how did you implement the PyTorch tensors? Do you have any math equation ready? No? So unless I type the code here, you won't type.
Is anybody done? You can submit the notebook so that we can open your notebook there on the screen.
So this is from my notebook. Use your practice notebook in this case, not the assignment notebook. These are a couple of imports that you can use. I provided that as part of the starter code. This is not assignment. Assignment I already gave you the code, but I wanted you to understand what is happening in that code. So here's a quick glance at it. We are using 3 different libraries. One, Torch, that is PyTorch. We use it for the tensor initialization for ANN in future. Besides that, we are using TorchWiz, that is for visualizing the tensors, how we are initializing, what are the math functions that we build. And display is used for displaying the graph that we build using the make dot. And this is how I initialize values of A, B and calculate C. Now I think it should be clear to all of you. So do you implement this? Do you see this, the final value of C? Or is there any trouble with importing the libraries? Let us know, because exercise 2 you need to use the same set of libraries. Torch, TorchWiz and IPython display. If it's done, just raise your hand so that we can proceed with the next steps. Okay, one student has done already. Done? Okay. And what about students on left? Few students have confirmed, who are seated on the right. If you are facing any issues with the module imports, please let us know. Done or issues? Issue? With which module? Torch. TorchWiz. And which IP? 203. Okay, what does it say? No module. Okay. And all of you are connected to 203 who are facing this issue. I'm sorry. He got 203. Anyone else who's connected to 203? TorchWiz is not working? And any other instances 203? Okay. Okay, so for 203 we will figure out some solution, but let's proceed further. Now since you initialize the tensors and you're calling backward on C, up to this point most of you have done the code. Next is a cell where I'm printing the data values. Remember we have data in the value class as well. So tensors, the PyTorch tensors also provide the same attribute, the class attribute, that is data. Additionally you need to call item. If you look at the API documentation, you will understand why is that so. But for now, this is the method signature that you have to use or call in order to print the data value of a tensor. A.data.item or B.data.item. So this will give you the data value. Now what about gradients? So for gradients, it is A.grad.item and B.grad.item. So value class also we implemented data, we also had a grad. Now the same is there in tensors. So basically we were mimicking not only the functionality of an artificial neuron, but we also drew inspiration from how PyTorch is implementing the tensor methods. So that is how we are keeping in line with the PyTorch library as well to mimic a neuron. Now since PyTorch is something which is already implemented, library has many useful methods, it's abstracted. So we are not dealing at the abstract level, we want to understand what's under the hood. That's the reason we implemented the value class. So up to this point, I think most of you can do it easily. Now additionally, there is some code in order to generate a graph for this tensor. For that I am giving you the code in the notebook as well for exercise 2. You don't have to worry about it. You can take a look at it when you have free time. So this is the final node graph that you see if you use TorchWiz and MakeDot. So it says the final output is C, which has value 5, that is in data, and then add backward is called, it accumulates the gradients, and here you see A and B along with data and gradient values. So whatever we did using value class and draw dot, we are doing the same thing but using PyTorch and Torch Vision. That's it. So exercise 2, I'll release it in some time. You can do it. It's quite simple. Yep. So I enabled week 2, day 1, exercise 2.
It's 10 minutes. It's doable.
It's quite simple. You should be able to see this. We open the student view.
Yes, you can just click on evaluate the previous one.
Yes.
Meanwhile, the previous one. Yeah. You can open up, yeah, you can discuss the problem.
Solution we'll discuss later because it's really
No, I'm talking about the day 2 second exercise.
Yes. So this is the student version, what you should see, that is week 2, day 1, exercise 2. Now again weight, data, bias, everything is taken from the previous class itself. So you know what are the weights, what are the input and what is the bias. The only difference is that you need to use PyTorch library for this assignment. You don't have to use value class, you have to use PyTorch library completely in order to solve this assignment. And additionally, in the end, you should be able to generate this graph. This is purely for visualization. Now let me walk you through the code. Imports I already provided you. This is to suppress warnings. You don't have to worry about it. Now here, under initialize tensors as defined in the problem statement, here is the part of the code that you need to include in order to initialize the weights, biases and input data using PyTorch. After that, I have the print statements already there. So you should be able to generate the gradient values. So you should initialize the tensors, you should call a backward and then you should be able to see the gradient values. Now there is only one visible test case because as I told you, this is to just draw parallels between value class and PyTorch. There is only one visible test case, so make sure this is passing. And there is a piece of code to generate the final graph. For that I initialized everything for you. You just have to run the cell, nothing else. Just run the cell and when you do everything correctly, the final cell output should look like this. So I am not able to zoom in further, but I think in your notebook view it should be clear. This is only a visualization of the different values. That's it.
Yeah, anybody facing any problem?
I think 203, the students who are connected to 203, they are not able to import Torch Wiz.
Okay.
Bhargava, 203 Torch Wiz not working.
Yeah, anybody submitted? One, two. Okay, did you got your feedback? Just wait, 2 minutes.
Still loading. Only one. There's only one green star. Evaluation, I clicked on it, it's going on. It's raining heavily anyway, you guys are stuck here for some more time. So please complete exercise 1 and 2, and if you have questions we can discuss to kill time. And also please make sure that up to exercise 1, the complete solution code should be running at your end. And I am expecting that the practice notebook that we opened the last week, incrementally keep adding the code to it and keep it ready. Because we will keep adding more methods to it and we will introduce newer classes. So you should have completely logically correct code. Otherwise you won't be able to follow the live coding sessions.
Yes, Sripooja, can you evaluate the first one? The first exercise. Yes, can you just evaluate? Yes, those who have done, most probably, of course you can leave, but Again, I just want to remind you that not more than 3 times absenteeism in Prashna Manch is more than that, it is not tolerated. You will be out. I'm just giving you, because I just want to be clear, because 20 marks will be given from your Tantric, your Tufan and the Prashna Manch score. Right? 20 marks will be picked up and will be given to you in your internal exams. Okay, those who finished the 41 were C, they can leave if you don't have any questions. Rest, because we are going to stop these programs today. If you want, please complete it by today and leave. Okay, any new student joined today? Only one student I know.